All right, last day of notes. First part, we're going to practice finding angles in the calculator. Using the calculator, that was a silly sentence. Angle in the calculator,
Thank you, everyone. That's all clear. One back to class. Have a great morning.
Got it. All right, and then second half, we're going to be solving equations with like double angles and half angles and 3/2 angles and stuff like that. All right, so solve using a calculator. You have a calculator part of the test and a no calculator part of the test. It's like, I'm not going to be like halfway through the test, oh my gosh, you guys stink without a calculator, get a calculator out. That was because last time, that was because we were like short on time and some of you were like, no calculator, I only have an hour, like that. So I was like, oh, get a calculator out. This time it's calculator, no calculator, two separate parts, okay? All right, so answer in degrees, inverse cosine of 0.6. So you just make sure that your calculator is in degree mode. And you type in inverse cosine of 0.6. We have a button for it, so you hit second cosine of 0.6. So notice that you have an inverse trig word followed by the ratio of 0.6. Your ratio is positive. Your answer should come from what quadrant? Quadrant 1, so your angle should be between 0 and 90. Then we get 53.130. I'm pretty sure on your test it has you round to 3 decimal spots. So 53.130 degrees. All right, number 2, inverse tangent of a fourth. So notice that you have inverse tangent. Your ratio is positive. Your calculator should search and return to you an angle from quadrant 1 between 0 and 90. So second tangent of a fourth, we get 14.036 degrees. And inverse sine of a negative ratio. Whoa. Our calculator is going to search in quadrant 4, and it's going to give us an angle that's negative between 0 and negative 90. So second sine of negative 0.35, negative 20.487 degrees. All right, the next 3 say to answer in radians. So you have to change your mode. So go to mode. If you're using one of these, it's next to the second key. Hit enter on radians, and then you have to quit out of it. So you hit second mode, which is your quit function. And then it wants us to find the inverse cosecant of negative, is that a 4? Negative 4/3. So do we have a button for inverse cosecant? No. So we are going to change the trig word. So you change it to its reciprocal. Who is the reciprocal of cosecant? Not reciprocal identity. Sine. So we change it to inverse sine. And if you change the trig word, you flip the fraction. So negative 4/3 flipped would be negative 3/4. So inverse sine of negative 3/4, you've got a negative ratio. So your answer should come from quadrant 1, quadrant 4, there it is. So second sine, negative, make sure you use the negative key and not the minus key. All right, so notice it gave you like a little tiny decimal. That's because you're in what mode? You're in radians, so don't freak out that your answer is this tiny. If you recall your radian values, you've got 0 radians, 3.14 radians, 6.28 radians, pi over 2 is 1.57, and then 3 pi over 2 is 4.71 radians. So if it's reversing your sweep, you're going this direction into quadrant 4, and you're getting a negative angle back. So 0 to negative 90 would be negative 1.57 decimal radians. So what was it? Negative 0.848. So negative 0.848 should be between 0 and negative 1.57. So that decimal radian value should make sense. And then your label wouldn't be a degree, it'd be a radian. All right, number 5, the inverse cotangent of root 5. Do we have a button for inverse cotangent? No, so we change it to tangent, and if you change the trig word, you flip the fraction, you flip the ratio. So instead of root 5, we would have 1 over root 5. You can enter it like this, or you can rationalize your denominator. If you rationalize the denominator, what is 1 over root 5 rationalized? Root 5 over 5. You just have to make sure that you close that parenthesis of the square root. So you've got the inverse tangent of what type of a ratio? Positive. So your answer should come from what quadrant? Oh. There we go. 0.42. Is that between 0 and 1.57? Then your answer should make sense. Be careful on the test. I already forgot what it was. Negative. No, positive. 0.44. Be careful on the test that you make sure that you are aware of what your mode is in, because if you remember back from day 1, we did, that was our reference angle days, but that was also the days that we wrote down the ratios of the 6 trig functions. And then you found theta and theta prime. You had like theta up here, theta prime up here, and you had sine of theta equals something, cosine of theta equals something. You know, you had all the, you know what I'm talking about? These angles that you found here were always what type of an angle? Were they radian or degree? They were degrees. So when you go to find these, your mode needs to be degree mode, okay? So if you are on these problems and you're getting tiny little answers, that means you're still in radian mode, so be careful on the test. All right, last one, inverse secant, you should change to cosine, so inverse cosine. What is negative 3 flipped? Negative 1/3. Ah, this is a cool one. The inverse cosine of a negative ratio is searched in what quadrant? 2. And it gives you a positive angle. If we were in degree mode, it would be between 90 and 180, but we're in radian mode, so it's going to be between 1.57 and 3.14. So when you type that in, you should get something bigger than 1.57, less than 3.14. Second, cosine, negative 1/3. Bada bing, bada boom. Hey, just passed 1.57. 1.911. Ah! 911. Quick, what's the number for 911? All right, that's a line on Saved by the Bell, but you guys probably don't even know what Saved by the Bell is.
I do.
Do what?
It's also on Little Rascals.
It's on what coast?
The Little Rascals.
Is it on Little Rascals? The 90s movie, Little Rascals? That's old, too, like me. Sandlot's 36 or 30 years old this year. I know, crazy. Who's seen The Sandlot?
How old are you?
I am proud to say 37.
Nice.
Yes. 37. You seem a lot older than that, Miss Barron. Really? Oh, you're so sweet. All right. Solve the trig equations over the interval 0 to 2 pi. So we're switching gears. We're done with the calculator. Put that to the side. I'm going to give you like 1, 2, 3. I've got 4 steps we'll write out for you. That way you can go back and reference them if you need to. And for the people who aren't here, they can have them written down as well. So step 1 is you are going to start by finding the general solution. So your general solution is your GV. But the general is kind of evil because really to find the general, you have to already know the principal of PV. So step one is to start by finding the general solution and make a little bullet. Ignore the number in front of theta. Ignore number in front of theta. So we're going to pretend that our problem that says the sine of 2 theta, this is technically a double angle. We're going to pretend that we're not working with the double angle right now. So you're just looking at the sine of theta equals root 2 over 2. And you're asking yourself to work with the inverse sine of root 2 over 2. You don't have to write this down on your worksheet, but this is what your brain and your eyes should be working with the inverse sine of positive root 2 over 2. So if we need the GV, we really need the PV. So your principal value is where your calculator searches. So a positive ratio has to come from quadrant 1. So we want the angle with the y value of root 2 over 2 from quadrant 1, pi over 4. So the first answer to the GV is the PV. So our general value is pi over 4 plus any other angle within one positive sweep that would also have a y value of root 2 over 2. So we know pi over 4 was quadrant 1. What other quadrant has positive y's? Quadrant 2. So using the idea of a reference angle being pi over 4, what's your pi over 4 before 4 pi over 4? 3 pi over 4. So your GV is pi over 4, 3 pi over 4, plus every two answers, 2 pi. So that's step 1. Step 2. Set solutions equal to the angle following the trig word. Set the solutions equal to the angle following the trig word. So this is where you don't ignore the fact that it's a double angle. So you're not just going to set it equal to theta, you're going to use 2 theta. And you're going to set up 2 equations because you have 2 answers. You have pi over 4 plus every 2 pi, and you have 3 pi over 4 plus every 2 pi. So the angle after, let me scroll back up just a little bit. The angle after the trig word is 2 theta. So we take 2 theta and we set equal to the first part of our general value, which was pi over 4 plus n2 pi. And you take the angle 2 theta and set it equal to the other part of your GV, 3 pi over 4 plus every 2 pi. All right, so third part would be to solve for theta. So we want to get theta by itself, and each we'll solve the first equation, and then we'll solve the second equation. We'll go back. To get theta by itself on the first one, how do you get rid of the 2? Divide by 2. So you divide everything by 2. So on the left-hand side, we would have theta equals, now be careful, pi over 4. So if you have a fourth and you cut it in half, you divide it by 2, you get an 8. So pi over 4 becomes pi over 8. Plus, what is n2 pi divided by 2? Just plus n pi. All right. Do I want to go ahead and do this next? We'll finish this part and kind of move into step 4 as well, but it'll all merge. So step 4. Once theta is greater than 2 pi, stop. So I'm going to go back over here. You have theta isolated. If the first angle, if the angle after the equal sign fits your range of values, 0 to 2 pi, it's one of your answers. Is pi over 8 greater than 0 but less than 2 pi? Yes. So this will be one of the answers. It then says that you get another possible answer every pi after that. So we take pi over 8, and we have to add pi to it. But to be able to add pi to pi over 8, they have to have the same denominator. So we would need, what is pi equal to in terms of pi over 8? 8 pi over 8. So we're going to add 8 pi over 8 and get 9 pi over 8. So if this answer is greater than 0 but less than 2 pi, it's also a solution. Is 9 pi over 8 greater than 0? Yes, because it's positive. Is it less than 2 pi? How do you know what is 2 pi in terms of pi over 8? 16. So it is less. So that's another answer. Then you go to 9 pi over 8, and you add another pi to it. So to add pi, we really have to add 8 pi over 8. So 9 pi over 8 plus 8 pi over 8 makes 17 pi over 8. Well, 17 pi over 8 is clearly greater than 0. Is it less than 2 pi? No. This is greater than 2 pi, so you do not accept it as an answer, and you stop with this column. So the only answers that came from 2 theta equals pi over 8 plus every 2 pi was pi over 8, or I said pi over 8, did I? Or pi over 4. Anywho, pi over 8 and 9 pi over 8. So we still have the other half of the GV to work with. So you do the same process. Isolate theta, divide by 2, divide by 2, divide by 2. Theta equals, what is 3 pi over 4 divided by 2? 3 pi over 8. Really, what do you just do to the denominator? You just times it by 2. You just double it because you're copy dot flipping. You're multiplying by the reciprocal. What's the reciprocal of 2? 1/2. So the 1 goes to the numerator. The 2 goes to the denominator. So we get 3 pi over 8 plus in pi again. So once theta is by itself, if the angle after the equal sign fits your range of values, 0 to 2 pi, it's another answer. Is 3 pi over 8 greater than 0? Yep. Less than 2 pi? Yep. So it's our third answer. And then we add pi to 3 pi over 8. So 3 pi over 8 plus 8 pi over 8 makes 11 pi over 8. Does 11 pi over 8 fit? Yes. And then from 11 pi over 8, if you were to add 8 pi over 8, you would get 19 pi over 8. Does that fit? No, you are greater than 2 pi. So how many answers fit the interval 0 to 2 pi? 4. And then your fourth step would be state all solutions. And because we have more than one, we put it in a solution set. So we would have theta is the element of the solution set. What's the smallest? Pi over 8. Next smallest? 3 pi over 8. Next, 9 pi over 8. Finally, 11 pi over 8. So this one had 4 answers that fit the value. You will not always have 4 answers. I can't give you like your if this, then this, if this, then that. You just have to go until you can't use any more answers. Sometimes you might have 4, sometimes you might have 3, you might have 1. Questions on that? Okay, if you were so inclined to check your answers, check this out. If you took pi over 8 and you plug it into the original problem, the sine of 2 times pi over 8 would be the sine of pi over 4. And what is the y value at pi over 4? Root 2 over 2. What was our next one? 3 pi over 8? Is that the next answer? So then if you did the sine of 2 times 3 pi over 8, the 2 would go into the 8 4 times, so you would get 3 pi over 4. Well, 3 pi over 4 is in quadrant 2, right? So what's the y at 3 pi over 4? Root 2 over 2. So you can always check your answers to your solutions if you want to. All right, next one. The tangent of 2 theta equals root 3. So the same steps. You start by finding the GV. Okay, and you ignore the number in front of the angle. So we completely ignore the 2. So you're just looking at, black. You're looking at the tangent of theta equals root 3. So we want theta equals inverse tangent of root 3. Remember, this is not worth points. If you want to write it, you go right ahead. If you don't want to, you don't have to. But this is what your brain and your eyes should be doing. You do have to state the GV, though. So your GV includes the PV. So where the calculator would search, your ratio is positive, so your answer has to come from quadrant 1, and it has to be positive. So this is one of our shortcuts because it's a tangent with a root 3. Tangents with 1, 3 belong to pi over 3. So that's our answer from quadrant 1. What other quadrant produces positive tangents? Quadrant 3. What's the pi over 3 down here? 4 pi over 3. So your GV, remember the tangents are the ones that have 2 possible answers. It has the or. Which one do you guys usually do? The 1 answer or the 2 answers? Show me ones. You do ones. Like legit. Get your hands up so I can see. 1 answer, 1, 2, 3. 2 answers. Okay, so more of you do 2 answers. So we'll do 2 answers. You can do, I'll also show you how to do 1 answer if you want to. But I'm going to do 2 answers first. So pi over 3, 4 pi over 3 plus every 2 pi. All right, so then you set your answers, your general value equal to the angle with the number that was in front of it. So 2 theta, I think my color was blue next, was it? Yeah, blue. So we'll do 2 theta equals pi over 3 plus every 2 pi, and then 4 pi over 3 plus every 2 pi. Oops, I forgot my 2 theta. 2 theta equals 4 pi over 3 plus every 2 pi. And we solve for theta. To get theta by itself, we divide by 2. Make sure you divide everything by 2. We get theta equals, what's pi over 3 cut in half? Pi over 6 plus n pi. All right, so if the first angle after the equal sign fits your range of values 0 to 2 pi, it is a solution. Pi over 6 is greater than 0 but less than 2 pi, so you're good. So now we get the next possible answer by adding pi to pi over 6. Are we going to add 8 pi over 8? No, what are we going to add? 6 pi over 6. You have to make it fit the denominator that you're working with. So pi over 6 plus 6 pi over 6 makes 7 pi over 6. Bigger than 0, but less than 2 pi. So it's another answer that works for theta. 7 pi over 6 plus another 6 pi over 6 gets you to 13 pi over 6. What do you guys know about 13 pi over 6? It's greater than 2 pi because what's 2 pi in terms of pi over 6? 12 pi over 6. So it's greater than 2 pi, so we do not want it. It's a bust. We got the other half of the answers to work with. Divide by 2, divide by 2, divide by 2. Theta equals 4 pi over 3 cut in half is 4 pi over 6 plus every pi. Now, be careful with this. Is 4 pi over 6 bigger than 0? Yes. Is it less than 2 pi? Yes. Is it reduced? No. 4 pi over 6 is actually 2 pi over 3. So 2 pi over 3 is one of your answers. Now, we had to add pi. What are we going to add pi to? If you add pi to 4 pi over 6, what do you, like, how much do you add? You would add 6 pi over 6, which is 10 pi over 6, which is greater than 0 but less than 2 pi, but reduces to 5 pi over 3. So instead of adding pi to 4 pi over 6, you could have added pi to 2 pi over 3. But what is pi? Oops. I wrote 2 pi, didn't I? 3 pi over 3. So you would get 5 pi over 3. So notice that you get the same answer either way you do it, except you just have to reduce. Okay? So does 5 pi over 3 fit? Greater than 0, less than 2 pi. Boom. All right. So if we add another pi to 5 pi over 3, what would happen? 5 pi over 3 plus another 3 pi over 3 gets you 8 pi over 3, which is greater than 2 pi. So how many answers? 4. We're going to have theta is the element of the solution set. What's the smallest out of our 4 circles? Pi over 6. So think about where these are located on the unit circle. What would be next? 2 pi over 3. And then 7 pi over 6, because it's the 30. And then 5 pi over 3 would be hanging out over in quadrant 4. All right, now, those of you, there was like 3 of you who like the GVs with 1 answer, right? If your GV was 1 answer, what was our first answer? Pi over 3. Then you would put plus in pi. And then we had 2 theta equals pi over 3 plus every pi, right? Divide by 2, divide by 2, divide by 2. We'd have theta equals pi over, oops, that would be a green color. Theta equals pi over 6 plus every pi over 2. So nothing canceled on that one. Does pi over 6 fit? Yep, wasn't that our first answer in our theta from last time? Sweet. So we're good. So then we take pi over 6 and we have to add pi over 2. But to add pi over 2, we would be adding 3 pi over 6, because you're only adding half this time instead of a full pi. Well, what's that get you to? 4 pi over 6, which reduces to 2 pi over 3, and that was our second answer. And then 4 pi over 6 plus another 3 pi over 6 gets you to 7 pi over 6. Wasn't that our third answer? And then 7 pi over 6 plus 3 pi over 6 gets you to 10 pi over 6, which reduced to 5 pi over 3. That was our last answer, wasn't it? And then if you take 10 pi over 6 and add 3 pi over 6 to it, you get 13 pi over 6, which is greater than 2 pi. So you get the same answers as you would by doing the 2 answers separately. You just, what you're adding each time is different, but you end up with the same solutions. So those of you who like 2 answers, you can keep doing it. If you like 1 answer, you can keep doing it. Okay? To the next. All right, so the last 2 examples were double angles. They were 2 thetas. This one is a half angle. All right, so you ignore the number in front of the theta. So the in front of the theta is technically 1/2. So you're just looking at tangent of theta equals -1. Theta equals inverse tangent of -1. So that's what we're working with. The next step is the GV, but the GV requires the PV, and the PV is the answer the calculator would give and where it searches. So where does the calculator search for inverse tangents of negative ratios? Nothing's in 3.
Oh, 4.
Yeah, 4. And it gives you what type of an angle? A negative. So what angle has a y divided by x of a 1 or a -1? Pi over 4, but because we're down in quadrant 4 with a reverse sweep, our GV is negative pi over 4. If you like to give 2 answers, the other angle would have to be in what quadrant to get a negative tangent? 2. And what's the normal pi over 4 there? 3 pi over 4. So negative pi over 4, 3 pi over 4, plus every 2 pi, or negative pi over 4 plus every pi. So if you are somebody who likes to do the 2 answers, we'll do the 2 answers on the board. If you're somebody who likes to do the 1 answer, you can just work out with the 1 answer on your paper. Or if you are the 1 answer and you want to do the 2 answer on your paper, whatever, or both, whatever tickles your fancy. So next step, we take the number in front of the angle and set it equal to our GV. So we've got theta over 2 on this one. So theta over 2 equals negative pi over 4 plus every 2 pi, and theta over 2 equals 3 pi over 4 plus every 2 pi. So after you split it up, you've got to isolate theta. On the last 2 examples, how do we get rid of the 2? We divide it by 2 because it said 2 times theta. Well, this one is already being divided by 2. So you have to multiply everything by 2. So we're going to have times 2, times 2, times 2. So we'll have theta equals, what is negative 2 pi over 4? Negative pi over 2 plus every 4 pi. All right, so you've got theta isolated, correct? And I've said a couple of times, if the angle after the equal sign fits your range of values, it's an answer. Is it greater than 0? No, because it's negative. So that can't be an answer. Can't use it. Well, we could try adding 4 pi to it. Tell me what you know about 4 pi. It's 2 full revolutions, right? And your answers are supposed to be between what? 0 and 2 pi. So think, well, it's not undefined. It's just going to be that this part is not going to work out. So if you're still like, what? Actually add 4 pi to negative pi over 2. Well, that means your denominator would need to be what? To be able to add a 2. 4 pi would need to become 8 pi over 2, right? Because what's 8 pi divided by 2? 4 pi. So add those together, get you 7 pi over 2. What do you know about 7 pi over 2? It's greater than 2 pi. So that left side of the GV didn't give us any answers. And the next one. How do we get rid of dividing by 2? So we'll have theta equals, so 2 times 3 pi is 6 pi over 4, which reduces to 3 pi, nice, 3 pi over 2 plus in 4 pi. So if the angle after the equal sign, when theta is solved, when it's isolated, if the angle after the equal sign is greater than 0 but less than 2 pi, you can choose it. Greater than 0? Less than 2 pi? So then it's one of our solutions. And then use a little common sense here. 3 pi over 2 is almost a full circle. It's at 270 degrees. And if you added 2 full circles to it, you would what? That made me dizzy. You'd be over 2 pi, like There's no sense in even like checking that. Like you should know if you add 2 full circles to something that's less than a full circle, you would be over a full circle. So out of this, how many answers do we get? Just 1. So if you wanted to put it in a solution set, you could, or you could just say theta equals, oh, I was purple for that step 1. Theta equals 3 pi over 2. So first problem had 4 answers, second problem had 4 answers, third problem had 1 answer. The last one. Cosecant of 3 theta over 2 equals 2 root 3 over 3. This is probably the hardest one. All right, so look at your trig word. You've got cosecant. I prefer working with sine, cosine, and tangent if possible, because those are the ones I'm better at, is my normal trig words. So if I want to work with one of my normal trig words, I change my trig word, I would change it to its reciprocal, who's whom, or sine. So I'm changing my cosecant to sine. My angle doesn't change. My angle that I'm working with is still 3 theta over 2. It's my ratio for that angle would change. My ratio would be 3 over 2 root 3. So my angle doesn't change. Do you want me to show why it doesn't change? Does anybody want me to connect to why the angle wouldn't change as the ratio? To make it make sense? Okay. All right, so 3 over 2 root 3. Ooh, looks like it's not on the unit circle, but what do you need to do? Rationalize. And some of you will be able to know what it is without actually going through the rationalization process. So you get 3 root 3 over 6, because 2 times root 3 times root 3 is 2 times 3, which is 6. And then 3 6 reduces to 1/2. So you end up with root 3 over 2. So the sine of 3 theta over 2 equals root 3 over 2. All right, so we need the GV. Let our eyes ignore that 3/2. We just work with the sine of theta equals root 3 over 2. And we're working with the inverse sine of a positive root 3 over 2. The inverse sine of a positive root 3 over 2. So the calculator searches for positive ratios in what quadrant? 1. And we need the angle from quadrant 1 that has a y of root 3 over 2. So if it has a y of root 3 over 2, it has an x of 1/2, which belongs to the pi over 3's. So we know our GV has pi over 3 in it. What other quadrant has positive y's? Quadrant 2. I don't have my right now, I can't see who's being shady. All right, what's the pi over 3 from quadrant 2? 2 pi over 3. So pi over 3, 2 pi over 3 plus every 2 pi. What's your next step? Vector. Now we go back and we take the normal angle, which was what? Or the angle that we ignored at the beginning. 3 theta over 2, or 3/2 theta, however you want to say it. 3 theta over 2 equal to the first half pi over 3 plus every 2 pi, and then 3/2 theta equals 2 pi over 3 plus every 2 pi. It's from intruder drill. It's from intruder drill. It's shot from intruder drill.
In my question, I don't interrupt in the middle of lesson.
Oh,
So
I mean, you have before.
I have, I try not. She's funny. She's funny. Mother Russia, not so funny.
You come back in 5. All right, 3/2. We got to get rid of that. You can do it in 2 steps, or you can do it in 1 step. To get rid of dividing by 2, you could multiply by 2, but then you also have to get rid of multiplying by 3, so then you would divide by 3. So if you do it in 2 steps, you multiply by 2, divide by 3. You do it in 1 step, use the reciprocal, which is what? 2/3. So theta equals, make sure you actually multiply and don't do 3 plus 3. So pi over 3 times 2 pi over 3 gets you 2 pi over, I just said make sure you actually multiply. 2 pi over 9 plus in 4 pi over 3. Nobody wants to talk now. Oh no. All right. So theta is isolated. First angle after the equal sign. If it's bigger than 0 but less than 2 pi, you're good. 2 pi over 9 bigger than 0? Yep. What is 2 pi for pi over 9s? Double that. 18 pi over 9. Because what's 18 divided by 9? 2. So if we get anything bigger than 18 pi over 9, we can't use it. So 2 pi over 9. I'm not using my right colors. So 2 pi over 9 is one of our answers. All right, so then we have to take 2 pi over 9 and add 4 pi over 3, but we need a denominator of 9. So we have to multiply by 3. I gotcha. So it's 2 pi over 9 plus 12 pi over 9 gets us 14 pi over 9, which we said earlier that 2 pi is 18 of them. So we're less, so we get to keep it. So if you were to add 12 to 14, you would get what? 26. Can you use it? No. I'm going to write it down just for notes purposes, but you guys don't have to. And then we have the other side to work with. So 2 pi over 9, 14 pi over 9 so far. Multiply them by that reciprocal of 2/3. So it's theta equals 4 pi over 9 plus every 4 pi over 3. First answer after the equal sign. If it fits, it works. Does 4 pi over 9 fit? Yep. Third answer. Now we know what to, oh, let me read that. Now we know what to add. 4 pi over 9 plus 12 pi over 9 gets us 16 pi over 9, which is less than 18. But if you were to add a 12, we would get a 28, which is a bus. So how many answers? 4. We need to put them in order if we can, which we should be able to. Theta is the element of the solution set, smallest pi over 9. 2. Next. 4. Next. 14. And finally, 16. All righty. 12:48. We wouldn't be in here. 10:48.